Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. In SN2 reactions, the rate depends on 1. Steric accessibility of the electrophilic carbon and 2. Electronic activation-deactivation at the carbon bearing the leaving group. Primary alkyl halides are generally faster than secondary or tertiary. Among primary substrates, electron withdrawing groups adjacent to the reaction center increase the electrophilicity of the carbon and enhance SN2 reactivity. Analysis of each option. A. CH2 is equal to CH, CH2Cl, allyl chloride. This is an allylic primary chloride. Allylic systems are reactive in SN2 because the carbon is primary and unhindered. Good reactivity. B. pH, CH2Cl, benzyl chloride. This is a benzylic primary chloride. Also reactive in SN2, similar to allylic. Good reactivity, comparable to A. C. MeO-CH2Cl, chloromethyl methyl ether MOMCl. This is a primary chloride with an oxygen atom directly attached to the alpha carbon. The oxygen lone pairs can donate into the system, but more importantly, the carbon is primary and the adjacent oxygen makes it an alpha-alkoxy halide. These are known to be highly reactive toward SN2 due to the inductive effect and the partial positive character on the carbon flanked by oxygen and chlorine. D. PHC is equal to O, CH2Cl, phenyl chloride alpha-chloroacetophenon. This is a primary chloride with an electron withdrawing carbonyl group directly adjacent to the carbon-bearing chlorine. The carbonyl group strongly withdraws electron density from the alpha carbon via both inductive and resonance effects, making the carbon highly electrophilic. This significantly activates the substrate toward nucleophilic attack in SN2. Alpha-halocarbonyl compounds are among the most reactive substrates in SN2 reactions. The carbon is primary, unhindered, and strongly activated by the adjacent C is equal to O group. Comparison. While allyl and benzyl chlorides benefit from transition state stabilization through resonance, phenyl chloride, option D, benefits from ground state electrophilic activation. The strong electron withdrawing carbonyl group raises the partial positive charge on the alpha carbon, lowering the activation energy for nucleophilic attack more effectively than resonance stabilization alone. Alpha-haloketones react faster in SN2 than simple allylic or benzylic halides. Why other options fail relative to D? A and B are reactive but lack the strong electron withdrawing activation present in D. C has an oxygen alpha substituent but oxygen is less strongly electron withdrawing than a carbonyl group in this context. Therefore, the correct answer is D. Therefore, the correct answer is option D.